we do not know if life has evolved outside our own planet. Of all the planets in the solar system, it is Mars that has an environment most like the Earth's. Like Earth, it has a rocky surface, and its gravitation is similar in strength to our own planet, which means Mars also holds an atmosphere. But does it have water? For decades, we have been sending probes to Mars to learn more about the environment of our neighbouring planet. Orbiters, landers and rovers have been to Mars, all looking for water, the essential factor needed for life. Its surface has valleys and deserts, but it is dry, with an average temperature of 50 degrees below zero. There are signs of erosion that look like they could have been carved by water. And Olympus Mons, the highest mountain in the solar system, is a volcano, but is it still active? In 2001, Mars Odyssey went into orbit around the red planet. One of its tasks was to map the planet's geological composition. Mars Odyssey's gamma-ray spectrometer could detect the presence of 20 elements, and its neutron detectors would look for water and ice in the soil. Planetary geologists already knew Mars's ice caps were frozen carbon dioxide, and the search for Martian water would focus on the poles. Odyssey's instruments found strong indications that water ice lay just below some parts of the planet's surface. The spacecraft was directed to look for chemical evidence of water, which should be recognizable because of its high hydrogen content. Hydrogen quickly combines with other elements, so if it is found on a cold planet, it is very likely to have teamed up with oxygen to form water. Researchers were surprised to get such a strong indication that ice was present, but they could not be certain about exactly how much water was there. Estimates varied between enough water to fill several large lakes to a frozen underground ocean. Odyssey's sensors could not show how far down the ice extended, and skeptics said the probe's findings were circumstantial and could be explained by other factors. The planet's poles were giving indications of an abundance of ice, but the international team of scientists was concerned that much more work would need to be done to confirm that Odyssey's instruments had really found evidence of water ice. Scientists became fascinated by what the finding meant for the understanding of the weather and geology of Mars. It seems to have once had water on the surface, lots of it. There are places that look like dried-up lakes or seabeds. Researchers began speculating that liquid water could exist in deep canyons. Work began on new Mars missions that could positively identify water or ice on the planet. The European Space Agency was preparing a two-part craft. Mars Express would go into orbit around the red planet and release a landing craft called Beagle 2. And the United States was working on a pair of rovers. The spacecraft would land at different sites that appeared to have been affected by liquid water. They would be able to analyze rocks and soil, and being mobile, they would be able to seek out interesting features. To refine its rover design, the American Space Agency NASA took a prototype to the Atacama Desert in Chile. It is the driest place on Earth. Rainfall is measured in millimeters per decade. Though it's much warmer than Mars, it's the best place on our planet to test a Mars rover. Zoe is pioneering new technologies of both robot mechanics and ways to detect life. Cameras act as eyes to track the terrain, and she is powered by solar panels. By understanding the absolute limits of life on Earth, scientists hope their search for life on other planets such as Mars will be more likely to succeed. The rover must be able to act with a degree of autonomy that allows it to solve problems in plotting a path to its target area. Each morning, a remote team gives the instructions for the day's work. On this day, the tests are centering on testing Zoe's skills at negotiating difficult terrain. To remotely control such a vehicle is not viable, Because Mars is at such a great distance from Earth, the control signals would lag too much to be of any use. Zoe is equipped with instruments to collect soil. It can detect samples worthy of further investigation by flashing different wavelengths of light at the surface it is passing over. Some natural organic materials, like chlorophyll or the nucleotide ATP, will fluoresce. If they are present in the soil, Zoe can detect them. During the nights, the rover stays in the field just as a Mars rover would. It's all part of the testing of the next generation of autonomous exploration vehicles. Lessons learned in the field are applied to the rovers being prepared for the trip to Mars. NASA's two rovers, named Spirit and Opportunity, were being readied for launch in mid-2003. This was a popular year for Mars missions. In that year, Mars passed closer to Earth than it had in the previous 60,000 years, and Japan, the United States, and Europe would all launch Mars probes. The rovers are solar-powered robots. They have 6 wheels mounted on a rocker bogie suspension system that ensures they remain on the ground when driving over rough terrain. A panoramic camera and a monochrome navigation camera are mounted on a mast, while 4 hazard cameras are mounted at the corners of the vehicle. Each wheel has its own motor, with the front and rear wheels having steering motors, allowing the rover to rotate on the spot. Average speed is 10 millimeters per second, because the hazard avoidance software causes it to stop every 10 seconds for 20 seconds to understand the new piece of ground it has driven onto. A duplicate rover was tested in the field to look for unforeseen problems that could arise in an uncontrolled environment. Meanwhile, scientists from NASA's Astrobiology Institute were studying ancient formations called stromatolites. These are layered rocky structures that result when blue-green algae trap fine sediment. For the first 3.5 billion years of life on Earth, stromatolites were the dominant life form.
So that's the study.
Studying these organisms could help NASA identify the unique atmospheric conditions created by primitive life on other planets. The stromatolites and other colonies of single-celled organisms were marooned in these Mexican lakes when the sea retreated more than 100 million years ago, preserving the life forms that thrived on the early Earth. It was these primitive organisms that added oxygen to the atmosphere, allowing it to support the more complex forms of life that emerged. NASA's hunch is that early Mars could have been populated by similar colonies of primitive bacteria. The indications of these life forms are preserved in rock formations, and the astrobiology team took a range of gas readings, cell and chemical samples from the formations, which look like clumps of coral dropped into the desert. If evidence that liquid water once existed on Mars can be found, then there is a chance that similar primitive life forms may have evolved there. Europe is also developing a robot that will explore Mars. ExoMars will be the first mission in the European Space Agency's Aurora exploration program. Scheduled for launch in 2013, ExoMars will build on the work of previous Mars missions in the search for water on the Red Planet. Mars Express was Europe's first mission to Mars. The spacecraft was launched on the 2nd of June 2003 from Russia's Baikonur Cosmodrome. The relatively low cost of the mission was achieved through innovative approaches and through the reuse of equipment developed for ESA's Rosetta mission. Soon after, on the 10th of June, the first of NASA's rovers was launched, followed 1 month later by the second. ESA's Mars Express arrived near Mars in December of 2003 and prepared for the separation of its Beagle 2 lander and to slow itself for entry into Mars orbit. As it approached, all was functioning as expected, and the signal to release the lander was given. Everything was working perfectly. But that was the last that was heard from the lander.
For your awareness, these are
Mars Express carried out its Mars insertion correctly. It was to act as a relay station for messages from Beagle 2, but nothing was coming through. The radio telescope at Jodrell Bank was focused on Mars, listening for the pulsing code from the lander, but all remained silent. Mars Express continued to search for its partner in areas away from the intended landing zone in case Beagle 2 had gone off course, but there was still no signal. The mothership settled into a polar orbit, and ground staff remained hopeful that their lander would eventually call home. The Europeans postponed other parts of Mars Express's mission. It would not deploy its large radar booms to search for subsurface water until it had a clearer idea of what had gone wrong. At the same time, NASA's first rover, Spirit, was arriving at Mars. The atmosphere, a parachute and landing rockets would each in turn slow the craft down, before bouncing to a landing on the surface. Everything worked perfectly, and ground control celebrated. After the airbags deflated, the protective petals of the lander opened, and the first rover, Spirit, unfolded. Then the camera mast extended, and Spirit rolled on to the Martian surface. The cameras began scanning the landing site, Gusev crater. 3 weeks later, Opportunity would land on the other side of Mars at the Meridiani Planum. The panoramic camera revealed a dusty red desert strewn with rocks. The two rovers were expected to function well for 90 days. It was feared dust would cover the rovers' solar panels and they would not be able to charge their batteries. But so far, winds have kept the panels clear, and more than 4 years after their landing, they are still operational. Both have found clues that water may once have flowed across the surface of the planet. Science was getting close to answering the question about water on Mars, but they still wanted definitive proof. In London, an inquiry was held to get to the cause of the Beagle 2 failure. At a press conference to announce the results, it became clear that nobody had any idea what had happened to the British-built lander. A list of around 12 possible causes was the best they could come up with. A crowd of cameramen and reporters gathered as a new lander, known as Phoenix, was about to touch down on Mars. The probe is designed to make the first direct measurements of water on Mars. It was aimed at a landing zone near the planet's north pole, where the Odyssey probe had registered strong indications of water ice. As Phoenix hit the atmosphere, the 3 active probes still in orbit around Mars were waiting to record the stream of signals the craft would transmit during its entry and landing. NASA's Jet Propulsion Laboratory made adjustments to the orbits of Odyssey, the Mars Reconnaissance Orbiter and Mars Express so that they would be in the best possible place on May 25, 2008 to monitor the landing. This information will allow for the better design of future landers. Mars Reconnaissance Orbiter's high-resolution camera was even able to photograph Phoenix suspended from its parachute during its descent through the Martian atmosphere. After 3 minutes beneath its parachute, Phoenix dropped its heat shield in preparation for the next phase of its landing sequence. Because Mars's atmosphere is much thinner than Earth's, the parachute alone is not enough to slow the lander to a safe landing speed. When the landing radar was able to detect the ground, Phoenix then waited for the right moment before jettisoning its parachute and backshell and firing its landing rockets for the final landing phase. In a final pirouette, the craft swung to align its solar panels in an optimum position. Back at the Jet Propulsion Laboratory, the ground crew could do nothing other than listen to incoming signals confirming each stage of the landing sequence. Phoenix was dropping at a speed of 8 kilometers per hour when it touched the surface.
Touchdown signal detected.
At a distance of 275 million kilometers, radio signals confirming a successful landing, travelling at the speed of light, took 15 minutes to reach Earth. Even so, Phoenix staff were jubilant when the signal for success came through. Initially, Phoenix sent back engineering information about system voltages, internal temperatures, and sensor function. It was days before the planetary researchers started getting pictures of Phoenix's neighbourhood. After 3 days on Mars, Phoenix extended its robotic camera arm. Every component of the craft had been sterilised before it left Earth. Again, there was celebration on the ground when the first pictures started coming in. The mission was scheduled to last for 3 months. Its landing site is above the Martian Arctic Circle, so Phoenix's solar panels will have constant sun during Mars's northern summer. Almost immediately, Phoenix found what looked like ice in a hard patch underneath its landing site, and changes in a trench it had dug with its excavation tool indicated some ice had turned to gas when exposed to the sun. But the scientists still wanted conclusive proof that there was water on Mars. Phoenix has a range of complex analytical systems, including several ovens to heat samples in an attempt to sniff out organic compounds. Unlike the twin rovers roaming near the Martian equator, Phoenix's lifetime cannot be extended very far beyond the 3-month schedule because it won't have enough power to survive the Martian winter. There was a problem when a short in one of Phoenix's test ovens threatened the instrument, but at a press conference, mission specialists said the fault had not reoccurred. The Mars Reconnaissance Orbiter was able to capture images of Phoenix on the Martian surface using its high-resolution camera. A wide image revealed the surface's rippled features that had led mission designers to choose the area as the landing site. A closer image shows the lander and its discarded parachute. Cracks in the ground around Phoenix are thought to be caused by changes in underlying ice. The cracks appear sharply defined because they are not covered by the fine dust that is so common on Mars. The area near the craft, accessible to its robotic digging arm, is reasonably free of rocks, which was good news for the mission specialists, as the excavator cannot cope with a hard surface. Some of the rocks appear to have been blown sideways by the craft's landing thrusters. After a week on the surface, tests were carried out with the digging arm. The pattern of operations is slow and methodical, and every move is carefully planned, and its success or failure is debated at length before another effort is made. After 2 unsuccessful attempts to deliver ice-rich soil to one of Phoenix's 8 lab ovens, researchers decided to collect pure soil instead. Surprisingly, the sample was mixed with a little bit of ice, and researchers were able to prove the soil had ice in it because it melted in the oven at 0 degrees, releasing liquid water. Finally, science had proof that water existed on Mars. It was the first piece of good news for a mission that, since it had landed, had been dogged by difficulties. The lander spent several weeks drilling into hard ice and had trouble delivering ice shavings into an oven. Back in Europe, ESA had made a big step forward in its Aurora exploration program with the completion of its first automated transfer vehicle. The unmanned cargo craft will initially be used to service the International Space Station, but it figures in the agency's longer-term plans for wider planetary missions, including the broader exploration of Mars. The automated docking system was developed in a partnership with the Russian space program. Both Russia and the United States are planning a manned expedition to Mars, and the ATV will be used in ferrying supplies and componentry to Earth orbit in preparation. A manned Mars spacecraft will be huge. It must be capable of carrying a crew of at least 6 and all their supplies for a return journey that would last several years. The Russian project, called Mars 500, is testing the endurance of 6 volunteers, locked in a ground-based simulator for at least 500 days. Russia already has detailed experience in long-term manned spaceflight. Cosmonaut Valery Polyakov holds the record for the longest spaceflight in history, staying aboard the Mir space station for more than 14 months. On his return, he said, "We can go to Mars." Space endurance and the effects of extended periods of weightlessness on the human body have been studied at the Russian Academy of Sciences since the 1960s. Even relatively short space flights can place humans under great stress, so cosmonauts and astronauts are selected very carefully. This latest research will build on Russia's experience in an attempt to determine whether humans are physically capable of surviving the voyage to Mars and back.